So a very good afternoon to all of you. Today we are doing the Kirchoff diffraction pattern of single slit and to verify the Kirchoff diffraction formula. So first of all you need to make the diffraction pattern in order to take readings. So first of all you will see here
This is a semiconductor
this is your
laser.
semiconductor laser, and from this you will open your slit. So I have opened, this is very actually a sensitive experiment, so I've already set it. I open the slit for particular slit width by rotating this knob. So initially how you will like open the slit width, I can tell you. Initially you will close it by rotating it clockwise, right? Clockwise rotation.
Close it by clockwise.
Yes. By
No, open it.
you will open it by clockwise rotation and you will close it by anti-clockwise. So when you will close it, there is a point will come when no laser will come in the output. So that is your starting point of the slit width. For example, there is my pencil. There is no pencil. Let me
Okay,
bring
let me.
pencil.
So here, one thing that we have to remember that this this knob is very sensitive. You see, so like without just it is slightly shifted without any circular movement, the slit width is varying. So first of all, we'll set it at 0.37. So we have to just remember this, that slit width change.
Okay.
And this is the rest of the setup. This is the apparatus, photo detector, and here is a light intensity meter. And in this we have to select the range 20 milliampere, because if we go in lower range, then the at peak position the intensity will vary very much, so it will go out of range.
Make sure that your whole spectrum you can easily calculate in one range. So you will trace your whole spectrum and see that if it is going outside of the range, then choose that range in between these three ranges, which is suitable for your whole spectrum. So make sure 20 milliampere is always suitable for whole spectrum, so make sure to choose 20 milliampere. Now I will tell you how you will take slit distance. For example, like here you will rotate it anti-clockwise, and after rotation in anti-clockwise there is a point will come when no laser will come in the output. Like when you will place a screen, there will be no laser in the output. Like here right now I'm getting laser, but at that point you will get no laser. So note down that reading. For example, that reading coming at 5, as you can see right now reading is 40,
37.
but right now reading is 37 before 40. So right now reading is 37, right now reading is 37, but it will come around 5 or 6, like 5 or 6. You will, when you will rotate it anti-clockwise, it will come around at 5 or 6, that your slit width will be completely closed, no laser will come at output. But as soon as you will cross your 5 or 6 reading, laser will start getting in output, and you will rotate it, and now I have rotated up to 37. So now take the difference of these two. So difference will be how much?
32.
For example, say my laser came at 37, output came at 37, and right now my reading is 37. So the slit width I have opened is equal to 37 minus 7 is equal to 30. So your slit width is 30. So right now my slit width is 30. So in that slit width I am getting the diffraction pattern in this form. Now after formation of diffraction pattern, how you will take readings? So since the least count is I guess 0.01, right?
Of
0.001.
this, of the slit, or of this one?
Let me open it.
For the
Since there is
slit,
a long time.
least count is I think
Don't need to
0.001.
remember slit. Least count. Essential count. Where is that?
In the starting.
Yes.
Yes.
So as you can see, it's 0.07 mm. Right now it is 0.30 mm actually. It's 0.30 mm actually. Right? In this form. Right now it is for 0.30 mm. And after that it will become,
So
you can
least
take
count is 0.01 mm
0.01 mm
of the slit.
So least count is 0.01 mm multiplied by the 30 I am getting, so it will become 0.30 mm simply. So that's how you will calculate your slit width simply. Now how you will calculate, was that actually? So right now, as you can see here, right now my spectrum is randomly set. So first of all, I need to bring it to the, as you can see here, this is my central maxima, first maxima, and this is second maxima. So just in the starting of the second maxima, you will bring your detector hole. Just in the starting of the second maxima, you will bring your detector hole. I guess it's not visible here. I'm actually tracing it back. Zadbhai, please can you focus it if you are able to? Let me show them. Actually, I'm bringing back. Right now, my pen, here is pen. Right now, my detector pinhole is at the second maxima peak point. Now I'm decreasing it. You can see in the intensity meter. Observing.
It is visible.
It is visible. Okay. Let me show. I'm
Remove the pen. It is visible.
As I'm further decreasing, as you can see here, it is in between second and third maxima. It is in between, and observe the intensity meter reading. Now I am increasing. I'm going to increase, and you will see the change. Now it is at minimum. Your first reading is this. Your first reading is this 0 0 position. 0 0 position is this. Consider this. Now bring it here. Now as you can see here, focus up. Now as you can see here, at 0 position, it is show the intensity meter.
It is to first explain the least count of this.
Okay, the least count of this meter is, circular meter is 0.01. I'm not going to show you how to calculate it. You can calculate yourself. The least count of this circular scale is 0.01. So for example, least count is 0.01, and I will rotate 50 division here. So after rotating 50 division, it will move 0.01 into 50 least count multiplied by the main scale count. How much it will be? Circular scale count 50 multiplied by, it will become 0.5. So first, after rotating 50 division, it will rotate up to 0.5 mm like this. Okay, so as you can see here, focus it. It is right now at 0. I will rotate it up to 50 divisions. So I'm going to rotate it. I'm rotating it from the 0. I'm rotating clockwise, and up to 50 I have rotated. This is my second reading. That starting reading was 0.00, and my second reading is at 0.5, 0.002. As you can see in the intensity meter, it is show the intensity meter. In the intensity meter, it is 0.00. Sorry, my hand was there. It is 0.01 or 02. Simply you can see. As you can also see here, it's 0.01 or 0.02. Now, let me tell you. Similarly, you will rotate again. You will rotate again up to 50 division. Like again, it will become 0. Again, it will become 0. 0, then 50, then 0. Now again 0. It is our third reading. 0.5 again have rotated. 1. It is our third reading. It's 0.02. In this, it's coming 0.06. It depends. It will may vary in the different form. It depends on your slit width. So I will keep increasing. I will keep increasing at 50 division. As you will observe that it will keep increasing since wait, actually the first maxima here, actually the first maxima of the second maxima peak is at 0.8, 0.7 or 0.8. That's why it is our first peak. You will get in your graph. Now as I will increase further, it will move towards right. It will move towards right side. That way, can you please focus so that I can show them? Like right now, it is at my second maxima peak. Right now, my detector keyhole is at second maxima peak. You can see here it is showing maximum. Now, as I am increasing further, you will see that it will go in between first maxima and second maxima, and it will decrease again. Its intensity will decrease again from 0.7 to 0.2. Again, as I will increase further, it will go to the maximum of the second peak. Now you will observe that it will go to maximum of the second peak. Now this is the maximum of the second peak, you can see here. From there you can see 0.23 is maximum of the second peak. As I will increase further, it will start decreasing. You can see 0.2, 0.3. Now you can see 0.2 after point. Now wait, and one
Okay,
more
it is
thing.
okay. It is
Okay.
understandable.
Okay, now let me tell you one more thing. Now your, as there is a problem also, like this scale will stop after certain time, so you will have to lose your this scale. So when you will take this out, your actual scale, it will stop there. Your detector point will stop there when we will remove this screw. Then you can continue, you can pull it back, and it will not change your detector point. Like I am taking it back, it will not change my detector point position. God, it is so too tight. Now I have made it 20 again. Now again I will insert a screw, and since after the, as soon as I will tight it, now my detector point is very variable again. It will vary as I will rotate my spectrum. Now you can see, as I will rotate my this screw, it will vary. God, this scale कुछ हो गया है. हिल गया मेरा पॉइंट, हिल गया. People like this, how you have to do. Actually there is a problem in the rotation. Maybe it's jammed due to some, I don't know.
It should be oiled properly.
It should be oiled properly.
No maintenance.
So I was telling, like similarly you have to trace your whole spectrum. After it you will get your peak after central peak, and after that you first in the right side, sorry, in the left side, you will also note down the first maximum and second maximum peak. Similarly you will get graph in this form: first maximum, second maximum, central maximum. On the right side you will also get first maximum, second maximum. Now these are the positions of your first maximum, second maximum, first maximum, second maximum. You will note down, and similarly you will pause it. Okay people, so now let's focus on the main part which you were waiting for, the calculation. हमेशा दिमाग खाता है. So for the calculation, tan alpha, which you need to calculate actually, where is that? You need to calculate the alpha, the position of first maxima. Tan alpha is equal to क्या होता है? Perpendicular by base. So perpendicular is a base, our distance between the, which is 1 meter from the source and the detector screen, you whatever you will call. 1 meter is this distance, and tan alpha is equal to a. So since there are two minimas, this and this, so from the graph, since there are two minimas on the left side and on the right side, so you will take average of these two, and only take average means this plus this divided by 2, so only one actual fine value will come. For example, here this is your first minimum on both sides. So from the central peak you will take this position and this position and take average of this. Like x maximum, for example, your x max is as 22 point something, your center peak is at 22 point something. First minimum on right, on the left side, it is at 13.89. On first minimum on the right side, it is on 31.37. So you will take the average of these two distances as we have taken here. You will take average from the x max minus x min, x max minus x min, from the center peak.
Okay, it is clear.
It is clear now. From the center peak, this distance and this distance average you will take, and it came out 8.25, and below you have taken the tan alpha is nothing. You will whatever you can say, tan alpha, since alpha, if you move tan here, it will become tan inverse. So tan inverse perpendicular by base. Similarly your alpha 1 will be this. Now from the formula you will calculate also alpha 1 sin inverse. From formula sin alpha is equal to n lambda by t, then alpha min 1 will become n lambda by, where n is order. For first minima it will become 1, for second minima it will become 2. Similarly you will calculate all the minimas from the position, like for second maximum you will take this from the center peak, you will take average of this position, this distance, you will take average of this distance, as well as you will take average of this distance, and it will give you the second maxima and second minima and third minima. First minima is this, second minima is this, third minima is this. These are for the minima. Now similarly you will calculate maxima also. For maxima you will take the from the center peak you will take the maxima position from here. Center peak, how much distance for the first maxima, and from the center how much distance for the first maxima. You will take average of both. Similarly, as you have considered in the case of minima, you will get alpha 1 for maxima and alpha 2 for maxima. And for the maxima, the formula is given in the sheet. You will put values here and you will get alpha 1 for the maximas also. Now for the intensity case, as we have calculated alpha 1 from the measured graph as well as from the formula. Similarly, for the measured case, we will calculate intensity by using this formula, and for the calculated case also by using the same formula, we will calculate intensity for both the maxima. Since intensity will be only for maxima, then here we are only taking the maxima conditions. Intensity of first maxima we have calculated in this form. Intensity of first maxima from the calculated formula in this form. Same like this.
Yes, sir.